There are unique Python patterns that are only useful in this language. My name is Andrew, and today I will show you 3 of those patterns and how you can use them. Before we start that video, I want you to go to my GitHub and look at my PyAssimilator module. I'm going to make a separate video regarding that module, that library, but for now just look at it, just start it, fork it, clone it, do all those things. So link is in the description, just look at it, start it, all that stuff. Okay, now let's go to our modules, or sorry, to our patterns. Yeah, PySimulator module was good, but let's go to our patterns. So as I said, there are unique Python patterns. And what I mean by that is that sometimes you have patterns like singleton. Singleton, maybe you know about factory, maybe you know about command, maybe you know about repository, or you know about DAO. All those patterns can be created in any programming language. So those are called design patterns. Of course, they have different names like design patterns, architecture patterns, all that stuff, coding patterns, but those are patterns that can be created in any programming language. However, today we're going to talk about different kind of patterns. So Python is such a unique language that there are patterns that can only be used in this specific language. And they make your coding a lot easier, a lot better, a lot more flexible, and all that stuff. The first pattern that we're going to look at is function as an object. So what do I mean by that? When we have a function, let's say we have function func, and that function, I don't know, returns 1 plus 1. What we can do is call that function for the result. So all of you know that we can use func and just call it. So we receive 2 as the result. However, we can also use that function as an object. So if I remove my parentheses, like this, and I call that or run that program again, we can see function func at some memory point. So what does that mean? Everything in Python is an object. Even class is an object. So we can use functions as objects. And what does it give to us? What we can do is we can save functions in separate variables. So we can say temp is function, and then if I print temp with the parentheses, I can call that function. So we can rename functions, we can do all that stuff. But one important thing is that you can use functions as parameters, as arguments. So if you worked with decorators, you already know about that, but all that stuff is really, really useful. And we're going to use that in one pattern that we're going to discuss later. However, one important thing in that thing is that we can use functions as objects once again. And what does it give to us is that we can create a function. So let's say test func, and that test func can replace our initial function. So what do I mean by that? Let's say that our initial function is not just 1 plus 1, but it's some heavy computation. So we have a function sleep that just stops our thread, so stops our program for 1,000 seconds. And then we return 1 plus 1. What is the problem here? The problem is that sometimes we want to test that function. So we want to test that function without running it directly. Why is that? Because if we run it directly, we have to wait for 1,000 seconds. So we have to run some heavy computations. We have to access some other external API or work with a database. That is a problem because if we want to test the function, we want it to just return the result that we expect. So what we can do is we can use a technique called monkey patching. And I have a separate video on that. And if you know about monkey patching, you know that there are lots of problems that are related to it. But what we can do is we can save our initial function to a temporary function, then create another function, test function, that kind of like does the same thing as our initial function, but only returns the result. So let's say that we need the result as 2. So 1 plus 1 is 2. We have to run that heavy computation to receive 2 at the end. We know that the result is going to be 2. So we can just say test function returns 2 without running all that computation. We need it for our project, but not for our tests. Because if we want to test how other functions work with test function altogether, we don't really want to run function every time. So what we can do, once again, is just to replace the function in our whole project. It may sound difficult, but the only thing that we do is we say temporary is function, function is test function, and then let's say that that's our project code, so main.py. If we run our function, so function result. If we run our function, the result is not going to be, so the function call is not going to be this function call with a slip. It's going to be test function. So what we can do is we can replace one function to another. And that is super, super, super useful. Once again, that's the first pattern, and I have a separate video on monkey patching, so I'm not going to talk about it here, not to waste your time. So that's the first pattern, monkey patching, or functions as objects in Python. And once again, when you use function with parentheses, you call the code. So you call it for the result. When you use it without parentheses, you just use it as an object. That's the first pattern. It's really, really useful. You must know it if you code in Python, but the second pattern is even more or far more interesting. So let's say we have a function called compute something. I don't know. Compute something, and that function has a, b, c inside of it. And let's say that we want to return sum of a, b, c, so a plus b plus c. But the thing is that when our users, and by users I mean programmers that use that code, because your user can be like the client that works with your application. So let's say I'm a user of PyCharm. I do not code PyCharm, but I just use it. Or I'm a user of YouTube, or you're a user of YouTube because you're watching that video right now. But a user can also be a programmer who uses that function. So compute something, user of the compute something is the person who coded like that. So who wrote print compute something. But the problem is that sometimes we want to make sure that the programmers who call our code name the parameters. Because if I just use 1, 2, 3, 1, 2, 3, what's going to happen is, of course, we're going to receive 6 as the result. But what if I want all the developers to say, okay, this parameter is A, this parameter is B, this parameter is C. I want them to name the parameters. Why can that be useful? Let's say you want to make a parameter that is not changed often, but when you change it, you need to actually show that you change it. So let's talk about math, for example. In math, in algebra, you have a quantity called E, or theta, or there are lots of names for it, but most people just call it E. And that quantity is sometimes, of course, it can be different, like epsilon and that stuff, but the thing is that that quantity is not changed very often, and it can represent a very, very, very small number. So let's say that when I use compute something, and every time I change my E to some other thing, so let's say E equals 50, I want our users to really name E as 50. So everyone knows that, okay, that function calls something with that parameter that is 50. If I just use 1, 2, 3, 50, that is not clear. So if we want to make sure that our users name their parameters, what we can do is use one pattern which is called named arguments only, named arguments only, whatever you like to call it. What you do is you just put a star, comma, and that's it. So everything after this star is going to be named. So if I run my code like this, what you see is that 1, 2, 3, 50 does not cut it, because we must name those arguments. And why is that useful? Once again, because you want your users to name your arguments. And how does it work? In Python, we have something called args and queued arguments, so quarks. Everything in between those things must be named, and everything after args must be named. If you just put a star, that means that everything that is unnamed, so unknown, or we don't know the name of that argument, we didn't put. So A equals 1 is going to be fine, but just 1 is not going to be fine. So everything that doesn't have a name goes to that star. Or if you want to use it, goes to arguments. That's it. That's how it works. And of course, what you can do is use ABC as positional arguments, so as normal arguments like 1, 2, 3. And then when you want to use an argument that must be named, what you do is you just put that star right in front of it. So if I call it with 1, 2, 3, yeah, and E should be, let's say, 10 by default. If I call it with 1, 2, 3, it's going to be fine. So it's going to be 6. But E, if I want to rename it as E, if I call it with, let's say, 20, nothing's going to work. But if I put it as E, boom. So that is another pattern in Python, which is called only named arguments, only named arguments. There is no real name for that pattern, but it's just very, very, very useful. So when you want your users to make sure, or when you want to make sure that your users name the arguments that they need to name, use that pattern. And I used it in my PySimulator module a lot. So once again, that's good for you as well. Okay, compute something is very, very good, but let's go to the most interesting pattern, which is the most, well, it's used almost everywhere. What is that? That is lazy evaluation. Let's say that we have a function, or let's say that we have main function, And that main function calls another function for results. So get results. Get results. We have a function called get results, and we once again sleep for like 1,000 seconds, like that, and then we return 1 plus 1 once again. So we want to get some results, but then the problem is that we don't use this results variable straight away. We can say return results, and in between those things we can say if, I don't know, if 8 is bigger than 4, print hello, or else print something else, like that, or like this. So the idea is that sometimes you want to run some heavy computation, so you want to make a query to the database, you want to do some heavy computation, you want to run some code, you want to do anything, but then your result is not used straight away. So what is the problem here? Let's imagine that we run that function. When I run main, I have to sleep for 1,000 seconds before I can go to if 8 is bigger than 4, print hello, all that stuff. But the thing is, I don't really need my results here on line 10. I need them on line 17. And most of you can say, okay, why don't you just do this? You just remove it here and you just put it there to return. Sometimes what we want to do is make sure that, I'll give you an example with the database. We want to make sure that our database query, so how we want to get our data, what we want to query, what kind of data we want to get from the database is ready. But the query itself does not run straight away. So once again, I use it in Assimilator a lot. So check out that module, and the pattern that I'm going to show you right here is implemented in that module as well. That pattern is called lazy command. So what's the idea? Idea is that we prepare our function, our method, so our code to be executed. We know all the arguments, we know all the things that we need to run, but we don't run it straight away. We have that prepared request in some function, or in some variable, sorry. And then once we need it, we run it. So the idea is that we only run that thing whenever we need it. Because once again, what you can do is return that results to some other function. Then that function returns results to some other function. Then we use the results in an object. Then that object is used by another function and all that stuff. So what you want to do is make sure that you don't call your code before you need it. And now I'm just going to implement that pattern, and then we'll look at how it works. Okay, so that's the whole pattern. Of course, you can improve it a lot, and I have like 7 or 6 functions in my ideal pattern in Assimilator. So go check it out as well, or I'm going to leave it in the description. I'm going to leave the link to this pattern. So what's the idea here? Lazy command is a class that has constructors, or init, with 3 things: command, args, and quarks. So what are those? Command is a function. So as I said, we can use functions as variables. So we can save a function inside of a parameter. And args and quarks are infinite arguments. So you can put whatever you want inside of those arguments. Args is arguments, so positional arguments, but infinite. Queued arguments are arguments with name, also infinite. So what we do is we save command to command, we save arguments to arguments, and we say queued arguments to queued arguments. Then we have a function run, and that function does the following. It uses self command with parentheses, so we don't store it as a variable no more, we just call it. But then we use arguments and queued arguments inside of that command. So basically, we can save all the arguments and the function that we need to call, and then call it when we use run. That's the idea. So let's look at how our get results changes. What I'm going to do is I'm going to add lazy parameter in here, and it's false by default. But if it's going to be true, if lazy is true, then what we do is we return lazy command that has the following. So our command is going to be get results. Our arguments are going to be nothing, but we have to provide lazy as false. So the idea here is that if lazy is true, then once we call that get result in a lazy command, lazy should be false. So just, if you don't get what I'm saying, just lazy always should be false in lazy command. That's just the rule. Okay, so lazy command, lazy is false, sleep 1,000, nothing changes here, that's it. Let's go to main. If we go to main, in get result we can call it straight away. So we can still call that function straight away and nothing changes. So let's run it. As you can see, we wait for 1,000 seconds, nothing changes. Of course, I'm not going to make you wait for 1,000 seconds, just nothing changes. The thing is that if we use lazy as true, and lazy is kind of like, it's a parameter that cannot be just true, you know? We should show the users that lazy is actually true, so we should make it named only. And for that case, we can use our star. So now another pattern is used inside of our lazy command. So star, so that lazy must be named. And I use the same in PySimulator. So get results, lazy is true. And now look at the result. If I run my code, as you can see, we receive hello straight away. But we don't call the function. Because if we want to call the function, what we need to do is in results, we need to call .run. So if I run it like this, look what happens. Hello is printed. So we run the code that is in between our preparation, so our function preparation, and our function run. So we can say it's between our database query preparation and database query execution. And then, as you can see, hello is printed, but we wait for 1,000 seconds afterwards. So what does it mean? We only execute the queries or any code, because lazy command can receive any code, only whenever we need it. That's the whole idea. And of course, there are lots of things on how to improve that lazy command. And if you have any suggestions, in the comments and on PySimulator GitHub page. But what we can do is change that run to another function called call. And that's what I like to do. So call in Python allows you to call your objects. As I said, every function is an object. And the only difference between a function and an object is that each function, well, there are a lot of differences, but each function has call inside of it. So each function has that call, and this call method, so this call magic method, allows us to call the function or call the object. If you still don't know what I mean, results is an object of class lazy command, so it's an instance. And then what we can do is we just say results parentheses. And if I go to those parentheses, okay, it cannot find the declaration, but basically when you say object, so you have class, then you say, so create that object, so we create that object here, lazy command, and then we use parentheses, we call that call function. Once again, the result is going to be the same, but now we don't have to use .run. We can just say results parentheses. That's it. So I also have a lot of things on lazy command, like we can say boolean from results, we can say iterator from results, so list from results will give us a list of all the results and all that stuff. But the most important idea is that sometimes what you need to do is make sure that your execution is not eager. So in programming you have eager and lazy. Eager is really, really bad because lazy, you don't waste a lot of memory when you're lazy. That's it. So that is another pattern, and those are 3 Python patterns that are really, really useful. Once again, watch my other video on monkey patching to know everything about it, but yeah, my name is Andrew. Once again, go to my PySimulator page. It's still in the development, but it's going to be released very, very soon. Thank you for watching, and bye-bye.